In lesson 02, we're going to review some of your information about complex numbers. I'm going to first describe to you a little introduction about your complex numbers, and we're going to go into how they were defined and do some simplifications and calculations with them. But eventually we want to be able to add, subtract, and multiply pure imaginary numbers and their complex numbers, and also take and use complex conjugates to write the quotients of complex numbers in standard form. So first of all, where do these complex numbers come with? Let's go through the evolution of your number system. From very early age, from 0 on up, your first number set that you worked was the natural number system. Your parents taught you how to count from 1, 2, 3, and so on. Eventually that number system became too small because you had to learn the concept of 0. Once you get to the whole numbers, we had to incorporate the meaning of 0. What does it mean to have nothing? Eventually that number system became too small because we had to include the numbers such as integers. Now integers included the negatives. So now we had to expand the left side of our number system, not only include 1, but a -1, 2 and a -2, and 0. And eventually that number system became a little small, and we included a larger set of numbers called the rational numbers. And the rational numbers, the base word in rational is ratio, and ratio means we can write it as a ratio of two integers, such as 1/2. That is a rational number. -1/3. They're both positive and negative. Whenever you write a ratio of two integers, they can be written as an equivalency as a decimal, but they're either going to be a terminating decimal or a repeating decimal in this case. So as long as they're terminating or repeating decimals, they're also considered a rational number. Eventually those became too small, and we introduced another number system that was outside of all these. These irrational numbers took on a life of their own. These were the square roots. When we ran into having to take the square root of 2, the square root of 3, and then when we got the square root of 4, that was a rational number, so it still fits in here in our rational numbers, but the square root of 5 was another one, square root of 6, and so on. All of these have something in common with their decimal representations. They never repeat and they never terminate, so irrational. That is your set of real numbers that you've studied up to this point. And then last year we incorporated another set of numbers called the complex. Now if you can remember why we needed the complex numbers, then you would remember that we had to take things such as the square root of negatives. For instance, the square root of a -1 was defined to be I. Now the pure imaginary number, square root of -1, is represented by the shorthand number I. I stood for the imaginary number, numbers that they thought weren't even possible until they started studying electromagnetic currents and so forth. So I was defined to be the square root of a -1, and we ventured away from that a little bit, and we said, well, what's that mean the square root of a -4? The square root of a -4 was. So when we did the square root of a -4, we said that was 2I, and here's some of the rationalization. We said that's the square root of 4 times the square root of a -1. The square root of 4 is 2, and the square root of a -1 is defined to be I, so we can more simply write it as 2I. Final example now is a -25. That would be 5I. So that kind of should pump your brain a little bit, prime it for what we're going to be looking at here, and that's a little bit of the intro into this investigation of this lesson.